Hello and welcome to Algebra 1, Lesson 32. In this video, we're going to learn about special products. So you might see the title of this lesson and say, what do we mean by special products? Well, essentially in this section, I'm going to give you some shortcuts for common binomial products. This is going to be a huge time saver for you moving forward. So I'm going to start out by just defining, again, what a binomial is. Okay, a binomial is a polynomial with two terms. So something generic, like let's say x plus y. And let's say we squared this guy. Okay, let's say we squared this guy. What is this equal to? If I said, give me an answer for this, give me a value for this, what would you say? Well, a lot of students make the mistake of just trying to distribute this exponent 2 to each term inside the parentheses. They say, okay, well, this is x squared plus y squared. That's a very, very common mistake in algebra. And this is wrong. This is not the right answer. Okay? And to understand why this is wrong, why it's not the right answer, let's go back to the definition of squaring something. Let's say I had the number 4, and I want to square 4. Well, what does this mean? It means I take this base 4 and I multiply it by itself, or I take the base 4 and I have two factors of 4. So this is 4 times 4, or 16. Well, by that same logic, if I have this quantity here, x plus y, and it's squared, well, the base, x plus y, needs to be multiplied by itself. So this is x plus y times x plus y. Right? I have two factors, my exponent is 2, of x plus y. If I changed that exponent up and I said, I have x plus y to the third power, or cubed, well, then I'd have three factors of x plus y. Right? You've got to expand this out. Very, very important that you understand that moving forward, because again, trying to say that x plus y, that quantity squared, is equal to x squared plus y squared, again, this is a very, very common mistake. Common mistake. So now that we understand the basic logic behind squaring a binomial, let's talk about how we can kind of get a generic formula going and speed our work up. So if we know that x plus y, that quantity squared, again, is equal to x plus y times x plus y, let's go through and use FOIL. Remember, we can use that to get the product of two binomials to get our answer. We would do the first terms, so x times x, that's x squared. Then we would do the outside terms, so x times y, that's plus xy. Then we would do the inside terms, y times x, which is yx or xy, doesn't matter, so plus xy. Then we would do the last terms, y times y is y squared, so plus y squared. So if I combine like terms in the middle here, I'm going to end up with x squared plus 2xy plus y squared. Now, this result is not unique. I can follow that same kind of format to get an answer when I have something that looks like this. If I have a binomial that's squared, I'm always going to end up with the first term squared. Okay, so here I have x as the first term, that ends up squared, plus 2 times the first term times the second term. So we have 2 times the first term x times the second term y, and then plus the final or last term squared. Right? In this case, I have y, so y is squared. You can kind of see I've written this out here. The square of a binomial, we have x plus y, that quantity squared. Again, it follows this format. First term squared plus 2 times the first term times the second term plus the final term or the last term squared. And you might not remember that right away, but you need to write that on a flashcard and kind of write some notes on that and just keep looking at it over and over and over again. And this is going to be one of the things that saves you so much time. Let me give you an example. Let's say I just throw something at you like x plus 7, that's squared. Without doing FOIL, can you give me an answer? Well, I can get an answer just by, again, using the general formula. So I know it's the first term squared, so x squared, plus 2 times the first term times the second term, or times the last term. So 2 times x times 7. 2 times 7 would be 14, so this would be 14x. And then plus the final term, or the last term, squared. 7 squared is 49. So without doing FOIL, I'm able to very quickly produce the result for the quantity x plus 7 squared. And if you don't believe that works, let's expand this, and I'll show you that I got the correct answer. So x times x is x squared, plus x times 7, that's 7x, plus 7 times x, that's 7x again, plus 7 times 7, that's 49. And this equals x squared plus, combine like terms, 7x plus 7x is 14x, plus 49. That's exactly what I got up here by just using that general formula. Now, there's another one that we didn't look at yet. And the only difference between the one we looked at already and this one is that there's a minus sign. So there's a slight modification. It's the same thing to remember. It's just that there's a minus sign in front of the 2xy. So, for example, if I had something like x minus 3, that's squared. Well, following this formula, I would have x squared minus 2 times the first term times the second term. So 2 times x times 3 would be 6x. And then plus your second or your last term squared. 3 squared is 9. So I get x squared minus 6x plus 9. Now, again, I could expand this and show you kind of the slow way that I got the correct answer. This is x minus 3 times x minus 3. So I get x squared, right, my first terms. And then x times negative 3 is negative 3x. Then negative 3 times x is negative 3x. And then negative 3 times negative 3 is plus 9. If I combine like terms here, negative 3x minus 3x is negative 6x. So I get x squared minus 6x plus 9. Now, one thing I want to call your attention to, I get a lot of students that use this formula, and at first they're making sign mistakes. So what I want you to understand here, when you use this formula, the signs are already kind of calculated for you. So don't worry about putting it in as negative 3. Just think about what number is here and what number is here, or it could be a variable or whatever you have. So whatever's in this position is here squared. Whatever's in this position and this position, don't worry about the sign. It's going to be 2 times this times this. The sign comes into play here. Okay, so if this is a negative, you put a negative there. If it's a positive, you put a positive there, right? If this was a plus, I would just put a plus there. But don't go through and start thinking of this as negative 3 and jam up your multiplication and say, okay, well, I have 2 times x times negative 3, you get negative 6x, and then you put minus there from the formula, you put minus a negative 6x, and you get plus 6x. Please don't do that. The sign is already figured out for you. You just need to be very, very simple here and say, okay, I have this as my first value, and this is my second value. Don't think about the sign. Just follow the general formula. All right, so let's do some quick practice. We have this quantity a plus b that's squared. So again, following the general formula, I know I'm going to take the first term and I'm going to square it. So a squared. Then I have plus. I'm going to take 2 times the first term times the second term. So 2 times ab. Then plus, I'm going to have the last term squared. So plus b squared. And again, you can check all of these. You just take this a plus b, this quantity squared, and you expand it. A plus b times a plus b. This equals a times a is a squared, plus a times b is ab, plus b times a is ab. Then lastly, b times b is b squared. If I combine like terms here, I get a squared plus 2ab plus b squared, which is exactly what I had right there. What about a minus b squared? Again, only difference is going to be that sign there. So I'm going to have the first term, which is a squared, then minus, right, because of that sign, 2 times the first term, which is a, times the second term, which is b, and then plus the second term squared, so b squared. So a squared minus 2ab plus b squared. And again, if you don't believe me, take this guy and go ahead and use FOIL to expand this. Write it as a minus b times a minus b, and verify that this is exactly what you get. All right, here's something a little bit more typical, and this is where it's really going to save you the time. So I have 2p minus 7, that quantity squared. So using my formula, whatever's in the first position, that's this whole thing right here, okay? The 2p is in the first position. That's my first term. So that's going to be squared. So the 2p is squared. And don't make the mistake of just writing 2p squared. The whole thing is squared. So the 2 is squared, and so is the p. So if I evaluate this, I would end up with what? 2 squared, which is 4, times p squared. Another common mistake would be to say, okay, I just have 2p squared. No, the whole thing has to be squared. Then I have the minus here, and then times 2 times whatever's in this position, so that's times 2p, times whatever's in this position, which is 7. 2 times 2 is 4, 4 times 7 is 28. So this would be minus 28p. And then lastly, I'm going to add whatever's in this position squared. 7 times 7 is 49. So I end up with 4p squared minus 28p plus 49. Now again, this is one that I feel that we should check. So I could show you we got the right answer. So we got 2p minus 7, that's squared. So this is going to expand out to 2p minus 7 times 2p minus 7. 2p times 2p, first terms. That's 4. 2 times 2 is 4. And then p times p is p squared. Okay, exactly what we have here. Then the next thing we'd have is the outer terms. 2p times negative 7, that's minus 14p. Then we'd have your inner terms. Negative 7 times 2p, that's minus 14p. Then the last terms. Negative 7 times negative 7 is plus 49. When we combine like terms here, we're going to end up with 4p squared minus 28p plus 49, which again is exactly what we got by using our shortcut. All right, let's take a look at another one. We have 6k plus 1. This quantity is squared. So again, what I want to do is take the first term, in this case that's 6k, and I want to square it. So don't just write 6k squared. Again, I'm squaring that whole thing. So if I square the whole thing, you know, a good practice is just put everything in parentheses, the 6 and the k, and square it. That way you know that the 6 is squared and so is the k. So 6 squared is 36, and k squared is k squared. Okay, then plus, we have 2 times whatever's in this position, which is 6k. 2 times 6 is 12, times k is just 12k, and then times whatever's in this position, which is 1. So 1 times anything is itself, so this is just 12k. And then lastly, plus whatever's in this position squared. So 1 squared is just 1. So we get 36k squared plus 12k plus 1. And again, we can prove this. We have 6k plus 1 squared. So this is 6k plus 1 times 6k plus 1. 6k times 6k is 36k squared. 6k times 1 is plus 6k. 1 times 6k is, again, plus 6k. Then lastly, 1 times 1 is 1. So we get 36k squared plus 6k is 12k plus 1. Again, exactly what you got there by using the shortcut. Let's take a look at 3x plus 2y squared. And again, all I'm going to do is whatever I have in the first position, I'm going to square that. So the 3 has to be squared, and so does the x. Again, this is 3x. That term is squared, the whole thing. Please don't just write 3x squared. That's wrong. So 3 squared is 9, and x squared is x squared. Then the next thing I want to do is have plus 2 times the first term times the second term. So 2 times 3 is 6. 6 times 2 is 12. So plus 12. And then, of course, the variables just come along for the ride. So x times y. So 12xy. And then lastly, I have the final term, which is 2y squared. Again, I got to square the whole thing. Whole thing is squared. So 2 squared is 4. Y squared is just y squared. Right? Please, again, don't just write 2y squared. A lot of students, they try to do this as fast as they can, and they make little small errors like that. This formula is only good if you practice it correctly. Right? If you don't do it correctly, you might as well just go through and do it the long way. So we're going to end up with 9x squared plus 12xy plus 4y squared. And again, let me do this the long way and prove this to you. So if I expand this, I get 3x plus 2y times 3x plus 2y. 3x times 3x is 9x squared. 3x times 2y is going to be plus 6xy. And then 2y times 3x, again, is plus 6xy. And then finally, plus 2y times 2y is 4y squared. So if I combine like terms in the middle here, I get exactly what I got from my shortcut, which is 9x squared plus 12xy plus 4y squared. Let's look at one final problem here, and we're going to move on to some other common formulas. And we can use this with fractions as well. We have 5/7 x minus 10/7 y. This quantity is squared. So again, I'm going to take whatever's in the first position, which in this case is 5/7 x, and I'm going to square it. So to square this guy, if I square 5/7, 5 times 5 is 25. 7 times 7 is 49. So that would be 25/49. That's the square of 5/7. And then we have x squared. And remember, I have this minus here, so that's going to go right there. And next I'm going to have 2 times whatever's in this position, which is 5/7, and then times x. I'm going to put these at the end for the variables, and then times 10/7, whatever's in this position, and then times y. I'm trying to just see if there's anything I can cancel, and there's not. So you're going to have 2 times 5, which is 10. 10 times 10 is 100. So this is going to be 100 over 7 times 7, which is 49, and then times xy. All right, then lastly, I'm going to have plus this guy right here squared. So 10/7 y. This is squared. So 10 squared is 100. 7 squared again is 49. And y squared is, of course, just y squared. So there's your answer. You get 25/49 x squared minus 100 over 49 xy plus 100 over 49 y squared. And again, if you want to, you can take this guy and you can expand it out, use FOIL, and you'll see that you get exactly this as your answer. All right, so let's move on now and talk about something else. So another common scenario occurs when we multiply two binomials, and one is the sum of two terms, while the other is the difference of the same two terms. Now, the result of this, we're going to learn later on, is called the difference of two squares. Once you start talking about things like this, you're going to know what that means. So the difference of two squares is something you're going to come across all the time. Kind of once you hit it in factoring, moving forward, you're just going to keep talking about it over and over and over again. So it kind of looks like this. You have x plus, let's say, a times x minus a. So the same terms are in the same position of each binomial. So I have an x in the first position here and an x in the first position here. I have an a in the second position here and then the second position here. The only difference here is that I have a plus here and a minus here. So when you do this, what happens is the middle terms from the FOIL cancel themselves out. So let me show you that. So x times x is x squared. The outer terms, x times negative a, is minus ax. The inner term, a times x is plus ax. So you can see those would cancel. And then a times negative a is minus a squared. So what happens is the middle part is going to cancel itself out, and you're left with x squared minus a squared. So in other words, the first term here is going to be squared minus the second term, which is squared, okay, whenever you come across this scenario. And again, this is referred to as the difference of two squares, right? Because you have subtraction involved, that's where difference comes in, and then each term is squared, so the difference of two squares. So here's kind of the generic formula that you probably see in your textbook. Again, it's x plus y times x minus y. And again, the first position of each one is the same. I have x here and x here. The second position of each is the same. I have y here and y here. You've got to have that. You can't have something like, x plus 3 times x minus 7. That's not going to work. You got to have x plus 3 times x minus 3, or x plus 5 times x minus 5. Or it could be, z plus 5 times z minus 5. But the first term in the first binomial has to be the same as the first term in the second binomial. The second term in the first binomial has to be the same as the second term in the second binomial. Has to be the same. The only thing that's going to be different is the plus here and the minus here. So you get this first term squared, so x is squared, minus your second term squared. Remember, the middle terms are going to drop out when you do FOIL because they're opposites. So if I was to show you this one more time, if we have something like x plus y times x minus y, if we use FOIL, x times x is x squared. The outer, x times negative y, is negative xy. The inner, y times x is plus xy. Right, you see those are going to cancel. And then the last, y times negative y, is minus y squared. So this is going to go away in the middle here. That negative xy plus xy is going to cancel. And what I'm left with is just x squared minus y squared. All right, let's take a look at some examples. So I have x plus 3 times x minus 3. So again, same thing here and here, same thing here and here. So I'm good to go. So all I need to do is take the first term and square it, and subtract away the second term and square it. So 3 squared, we know would be 9. So this ends up being x squared minus 9. And again, you can verify this just by using FOIL. X times x is x squared. Let me kind of write this out real quick. Then the outer, x times negative 3 is minus 3x. The inner, 3 times x is plus 3x. So those are going to cancel. And then the last, 3 times negative 3 is minus 9. Right? This cancels. And again, you end up with x squared minus 9. So now we have 6x plus 1 times 6x minus 1. So again, the first term is the same in each case. The second term is the same in each case. Just the plus and the minus is what's differing here. So then the first term is squared. Again, don't just write 6x squared and move on. Very, very common mistake. You've got to square the whole thing. The 6 and the x are both squared. 6 squared is 36. X squared is x squared. Then minus. I'm going to take that second term, which is 1, and I'm going to square that. We all know 1 squared is just 1. So this ends up being 36x squared minus 1. And again, go through and use FOIL and verify that I got the right answer. All right, what about something like 3n squared plus 1 times 3n squared minus 1? So 3n squared, and then 1 and 1. So that works out. So we're going to take our first term, 3n squared, and we're going to square it. So think about this, 3n squared, and we're going to square it. So 3 squared is easy, that's 9. What is n squared squared, right? If I have n squared, that means I have n times n. And let's say I square that guy. Well, that means that I'm going to have this twice. So I have n times n times n times n, or n to the 4th power. Again, this is found using the power to power rule. So I just take the base and leave it the same, and I multiply the exponents. So 2 times 2 would be 4. So this is n to the 4th power. Then I'm subtracting away. I have this term here, the second term, and that's going to be squared. 1 squared is 1. So we end up with 9n to the 4th power minus 1. All right, what about something like x plus 1/2 y times x minus 1/2 y? Well, again, I'm looking at what's in the first position here. I have x and I have x. What's in the second position? I have 1/2 y and 1/2 y. So we're good to go there. So I'm going to take what's in the first position, which is x, and I'm going to square it. And then I'm subtracting away what's in the second position, and I'm going to square that. So if I square 1/2 y, if I square this whole thing, 1/2 squared, 1 squared is 1, 2 squared is 4. So this would be a 4 here. And we know that y squared is just y squared. So we end up with x squared minus 1/4 y squared. All right, what about 9m squared minus 4n times 9m squared plus 4n? So again, 9m squared, and we're looking at 4n and 4n. So we're good to go there. So we'll just start out. We have this first term, and that's going to be squared. So 9m squared is going to be squared. So what's that going to give me? Well, 9 squared is 81, right? 9 times 9 is 81. M squared raised to the power of 2. Again, use the power to power rule. Base m is going to stay the same. Multiply exponents. 2 times 2 is 4. Now I'm going to put a minus there. My second term is going to be squared. So I'm going to have 4n, and that's going to be squared. So the 4 and the n are both squared. Again, very important you don't make that mistake. 4 squared is 16, and then n squared is just n squared. So I'm going to end up with 81m to the 4th power minus 16n squared. All right, so lastly, let's look at a binomial that is cubed. And this formula is a lot more difficult to memorize. The formulas I gave you up to this point are very easy. You can memorize them after about a day's worth of practice. This one you kind of have to work on, but I'm going to tell you that it's more rewarding and it saves you much more time to memorize these, because when this comes up on an exam, if you've got this down packed, this is going to save you a solid, let's say, minute and a half of you cranking stuff out at minimum, right? So if you know these off the top of your head and you're confident in your ability to execute the formula, this is the biggest time saver that you're going to have for your kind of basic Algebra 1, Algebra 2 test that involves cubing a binomial. So I have that a plus b, that quantity is cubed. You get a cubed plus 3 times a squared b plus 3ab squared plus b cubed. So essentially you have the first term cubed. Then you have 3 times the first term squared, then times the second term. Then plus 3 times the first term times the second term squared plus the final term cubed. Now, here's kind of the trick to remembering this. You know that you're going to have your first and your last term that's going to be cubed. Okay, so what I do is, if I can't remember, I write those out first. So let's say I had something like, I don't know, x plus 2, and that's cubed. So I know I'm going to have this first one cubed, so x cubed. And I know I'm going to have the last one which is 2 cubed. So plus 2 cubed is going to be 8. Let me write that way down there. Now in between, I can remember the number parts here because the cube part is a 3. So I know I have 3 and space, space, and then plus 3 again, space, space. Now all you need to remember is that in each instance, one of them is going to be squared and one of them's not. So in other words, in the first instance, this first term is squared, so I get x squared. And the second term is not, so times 2. And 3 times 2 is 6, so I can go ahead and erase this and put 6 for now. So 6x squared. Now in the last one, I put x squared, the first term. So in this one, I'm going to make the second term squared. So 2 squared is 4. So this is going to be 4. And then the other one is going to be to the first power. So 3 times 4 is 12, so this is going to be plus 12x. So I get x cubed plus 6x squared plus 12x plus 8. And that might not be the way you remember it, but this is always, if I get stuck for a minute, I remember that, okay, I know these first two. I know I'm going to have first term cubed, second term cubed. And I know that I'm going to have 2 spaces, each with a 3. And I know that each one of these is going to be used in those spaces. One's going to be squared in one instance, the other's going to be squared in the other instance. So once I remember that, I just kind of go through a process of, writing it out and then do that 3 or 4 times and then I'm good to go. Now for the other one, it's a little bit more difficult to remember. Because of the minus sign here, you got to remember that you have a minus sign here and then here. So it's right before the second term and right before the final term. So that's just something you have to remember. So for example, if I had something like x minus 2, that cubed, everything would be the same. So I would have x cubed, but then the signs would be different. So this would be minus 6x squared plus 12x and then minus 8. All right, so let's take a look at an example. We have x plus 4, this quantity cubed. So again, I know that I'm going to have this first one cubed. And I know I'm going to have the last one cubed. So let's write that way over here. Let's put plus 4 cubed. We'll go through and do the math in a little while. We know that 4 cubed is 4 times 4, which is 16, times 4 again, which is 64. We'll just leave it as 4 cubed for now. Now I know that I'm going to have plus something else, right? And let me kind of scoot this down a little bit. Now, just think about this right here. This is going to be my number, so 3 and 3. Then just think about these two. One of them is going to be squared in one case, and the other is going to be squared in the other case. So in other words, in the first case, it doesn't matter the order that you do this in. So I could say in the first case, I'll just square the first one, so x squared, and the second one won't be squared, so times 4. Then in the second case, the 4 is going to be squared. So times 4 squared times x. Now this one's not squared. So again, this is kind of how I remember it. It's my thought process. You can use it, or you can come up with something on your own, or maybe there's another tutorial out there that makes more sense for you, but this is how I remember it personally. So then I go through and just simplify. So then x cubed plus 3 times 4 is 12, so 12x squared plus 3 times, we have 4 squared is 16. 3 times 16 is 48, so that's 48x, and then plus 4 cubed, which is 64. So that's your answer. And, if I didn't sit there and kind of write things out, if I was on a test and kind of did that in my head, I would probably have that answer in under 10 seconds, right? Whereas if I went through and had to expand this right here, this x plus 4 cubed, let's just think about how long this takes. You have x plus 4 times x plus 4 times x plus 4. Well, I could save myself a little bit of time because remember, this right here is the same thing as x plus 4 squared, right? So I already know what that is. That's x squared plus 2 times 4, which is 8, times x, so 8x, plus 4 squared, which is 16. So I could save myself a little bit of time with that, just using that formula. So this is x squared plus 8x plus 16, but I've still got to go through and multiply this guy by this guy. So I've got to do x times x squared. So x times x squared is x cubed. I've got to do x times 8x, that's going to be plus 8x squared. I've got to do x times 16, that's plus 16x. And then I've got to do 4 times this. So 4 times x squared is plus 4x squared. 4 times 8x is plus 32x. 4 times 16 is plus 64. So now I would combine like terms. So I have x cubed plus 8x squared plus 4x squared is going to give me 12x squared. Then plus 16x plus 32x is 48x. And then plus 64. So I got the same answer here, but it took me a lot longer. And remember, I still used a shortcut. I still went through and said, okay, I know that part of this, x plus 4 times x plus 4, I already know the formula for that. So if I had went through and did FOIL for that first to get this first kind of answer, that would have taken even longer. So you can see already what a tremendous time saver this is going to be for you. All right, so now let's take a look at z squared y minus 5y, and this guy is cubed. So again, just trying to get a process for you to remember this. You'll always remember that the first guy is going to be cubed. Now, the second term, you have a space, then plus, you have a space, then minus. Remember your signs, before the second term and before the final term. So the final term is this guy right here, the 5y cubed. Now, what's going to be in the middle positions? Well, again, it's the same thing. It's 3. Remember that exponent is 3. So it's 3 here and 3 here. And then in the first instance, you square the first one. So that's z squared y, that guy squared, times this guy, 5y. In the second instance, you square the second one. So z squared y times, we're going to do 5y squared. I'm kind of running into stuff, so I know it's, let me kind of scoot this down a little bit. And now I can just simplify this. So z squared cubed, z stays the same. 2 times 3 is 6. Y cubed is just y cubed. Then minus. I have 3 times 5, that's 15. And then let's think about this. We have z squared squared. That's z to the 4th power. Then we have y squared. Then we have times y out here. So y squared times y is y cubed. Then plus. I have 3z squared y. Then we have 5y, that's squared. So 5 squared is 25. 25 times 3 is 75. Y squared is y squared. So you'd have z squared y times y squared. Y times y squared is y cubed. Then minus, lastly we have 5y cubed. 5 cubed is 125. And then y cubed is just y cubed. So we get z to the 6th power, y cubed, minus 15z to the 4th power, y cubed, plus 75z squared, y cubed, minus 125y cubed. So this is a perfect example of how much time you would save using this generic formula versus, going through and expanding this into z squared y minus 5y times z squared y minus 5y times z squared y minus 5y. Go ahead and do that and see how long it takes you versus doing it this way, and verify that my answer here is correct. Again, z to the 6th power y cubed minus 15z to the 4th power y cubed plus 75z squared y cubed minus 125y cubed.